Hello, everyone. Welcome to the talk of hacking hosting providers for fun and profit. And of course, also welcome to the Lead Up Live event hosted by Intigriti. This will be a super cool night with some really nice talks, which I'm sure all of you will enjoy. So let's get right into it with a quick Who Am I? I'm Tom. I work as a penetration tester and red teamer at Entity Belgium. We also do a lot of other cool stuff when it comes down to breaking and attacking things. In my spare time, I do bug bounty hunting on several platforms and targets. But the last couple of years, I caught an interest in hosting providers because I think it's a cool target and also because they provide a large attack scope. So this talk will actually cover some of the most impactful bugs and bug types that I discovered during my research. So the agenda for this talk will first be an intro to hosting providers and the services they actually provide. Then after that, we'll look at the risk associated with those services. And lastly, the most interesting part, we'll look at three separate vulnerability types. The first one is a code execution bug that I found during my research. Then the next one will be some vulnerabilities in regards to Symlinks. And lastly, we'll cover some database vulnerabilities. So hosting providers actually offer a lot of different services. The main focus, of course, is on hosting websites and applications. But apart from that, they also offer DNS and domain configuration, email packages, voice over IP infrastructure, and so on. Our main focus for today will be shared hosting packages. So below, I listed a few of the most common features that are available inside the platforms to actually manage your hosting package. So first one is cron jobs to add scheduled tasks to your application. The second one is CMS installation if you would like to have a WordPress or Joomla or some other CMS installed. Next one, there are sometimes predefined application installations that you can just click and install. Think about maybe a calendar application or some forum framework. Then we have SSH FTP configuration to actually upload and download files from your web root. And then lastly, there's general management to manage your SSL certificate, SSH keys, and stuff like this. Running your application on a shared hosting package also means that the infrastructure behind it is being shared with other users and applications. Here we have a quick overview of how this is being managed by hosting providers. So user 1 and user 2 each have their own little file system here that is available on the appliance, which we call a webroot jail, or jail for short. Whenever user 1, for example, tries to access the files inside his webroot, he will use SSH or FTP and will land in his own controlled environment. Note that he is not able to access the files of user 2 or the files available on the appliance file system. Now, we will have a look at one method to escape our jail and actually compromise all users on the same appliance. The first vulnerability we'll have a look at is command substitution. This basically takes the output of a specified command and uses it as an input for a second command. Now, the interesting part here is that the substitution is already happening before the second command is being executed. So we'll use this in order to execute code before we end up in a jailed environment of the user. There are two ways to perform command substitution. One is with a dollar parentheses syntax, and the other one is with backticks. So in the following example, we'll use substitution to perform a DNS lookup. We can see that the whoami command is being prepended to a burp collaborator URL. And in the output, we can see a lookup has been performed to root.burpcollaborator.net. This means that the whoami command was already executed before the NSLookup is being run. So this is more of a realistic example of how we can use this to exploit shared hosting instances. So most probably there will be a high privileged account running a cron job service to manage all these different cron job entries made by different users on the same appliance. So if we look at the following example, as user 1, we add an entry with the regular whoami command, but we will also include the command substitution version of the whoami command in order to exploit the cron job service. So if we look at the output now, the output of the first command is as we expected user 1 because it's being run in the controlled environment in the jail of user 1. But the output of the second command is actually the name of the high privileged account. So in this case, root, because the command is already being evaluated before the impersonate script is being run. So now we will look at some real-life examples of command substitution vulnerabilities being present in hosting provider platforms. So all evidence shown here is taken from real-life bug bounty reports I sent to several programs. So right here you can see the cron tasks panel of one of the targets. So you can see we are adding a cron job that runs every minute, and at the bottom of the page we can specify our commands. So in our case, we used command substitution with a reverse shell payload that is pointing to a VPS that I have. So to determine if the vulnerability is working or not, we should also look at the output without performing command substitution payload, for example. So what if we just SSH into our shared hosting instance and perform a whoami and an ID command there? So we can see we're running as user WMK and so on, and we're not part of any root groups. So this is inside our jailed environment. So what happens if our cron job that contains our payload executes? So we set up a listener to catch the incoming connection for our reverse shell payload, and we can see right off the bat that we are running as root in the shell prompt. And to further verify, we also performed some additional commands like whoami, ipconfig, and a directory listing of the /root directory that is only available to root user. So this confirms we escaped our jail and we're now ready to compromise other users on the system. So the second example also includes a command substitution vulnerability inside the cron job feature, this time inside another hosting company. So once again, we add a cron job entry that runs every 5 minutes. And in the script input field, we can add our payload. So we can see now we are doing curl with the contents of a file as post body because a firewall actually prevented us from opening a reverse shell connection to our VPS. So once we received the connection, we got the contents of the file. And this time we went a little bit further. So we enumerated the file system for a bit and also extracted the web.config file, which is a file that includes a lot of secrets like database credentials from another user. So we accessed another web root and extracted that file. So this is also a perfect example of using command substitution to escape your webroot jail and access other users' webroots and extract really sensitive data. Okay, so the next feature we'll look at are CMS installs. So most hosting providers allow you to easily install WordPress, Joomla, or some other CMS directly from the web control panel. However, this means that some elevated account needs to access your jailed webroot in order to install the necessary files and databases. So one way to do this, for example, is to issue a WP core install command inside your webroot with user provided values. So for example, domain, title, username, password, and your email address. So this opens new possibilities for us as an attacker to inject command substitution payloads. For example, in the title field. So if we specify a title that contains command substitution payload, that might be executed as the elevated account instead of inside the jailed environment. Okay, again, we are looking at a real-life example I submitted to one of the programs. So here we can see a WordPress configuration panel that is available inside one of the hosting provider targets. So here we can see the custom input fields we mentioned earlier inside of the WP core command. So we have to provide a domain name, path, block title, and so on and so on. So inside the block title field, we provided a bash reverse shell payload that is contained inside a bash substitution syntax here. So whenever we initiated the WordPress install by clicking the create button, we would catch a reverse shell on our VPS. So after further enumeration, we found a roundcube configuration file which contains plain text, username, and password. So this is a perfect example of an installer service on the backend that uses an elevated account and tries to install a WordPress instance inside your jailed webroot, but actually executed the code inside your block title payload. Before you guys get tired of this command substitution stuff, it's time to look at one more example of this specific vulnerability class. So hosting providers allow you to SSH directly into your jailed environment to perform some file operations or to change some permissions. Now, in addition to password-based SSH security, they also allow you to upload your public key to their web platform in order to improve the SSH security. Now, that also implies that this uploaded key must be checked for validity and format. One way to do this is, for example, to echo your key and pipe it to SSH keygen with some specific flags. And based on the return code, they can actually know if it's a valid key or not. Now, we can see inside our public key, we have the username at hostname part. Now, that also adds a possibility to add a command substitution payload inside one of those fields. Surprise, surprise, we'll have another look at a real-life vulnerability that I submitted on a bug bounty target here. So as we mentioned on the previous slide, the username at hostname fields can be used to include a command substitution payload. So what we see here is a curl command that will have the output of the hostname command posted as a post body to a burp collaborator endpoint. So whenever we try to upload this on a vulnerable target, which we can see here. So this is a SSH key configuration panel of a hosting provider platform. So we can see we included our malicious public key here. And whenever we try to add that SSH key to our account, the backend will try to validate the format and validity of our malicious public key. So when we monitor our burp collaborator client here, we can see the HTTP requests coming in that contain the host name of the backend server. So this verifies we have a successful remote code execution on the backend server that tried to validate our public key. Now it's time to wrap up the command substitution topic, and we'll have a look at some other cool stuff now. Our next topic for today will be Symlink vulnerabilities. So a Symlink is basically a file that points to another location on the file system. Now, of course, we can abuse this to eventually target files on other web routes or on the main appliance file system instead of our jailed web route we mentioned earlier. So we'll have a look at two possible attack scenarios here in regards to Symlink vulnerabilities inside hosting providers. So the first one we're seeing here is whenever we create a Symlink inside the jailed web route of user 1 that actually points to a file inside the hosting appliance file system, which we do not have access to. Now, it's important to know that whenever we initiate an action inside the web control panel of a hosting provider, that often initiates an elevated user or process that actually performs the requested action inside your jailed web route. But if that process or users follows your Symlink, it will actually perform that action on the hosting appliance file system instead of your jailed web route, because it follows the Symlink. Now, this can be abused to compromise the entire hosting appliance and other users that are running on it as well. In the second scenario, we will add a Symlink inside the web route of user 1 that points to the web route of user 2. Now, again, if we initiate an action on the web control panel of the hosting provider, let's say add a file, for example, then the elevated process or user will try to access the Symlink on user 1, but will eventually write for example, a web shell in the web route of user 2, which means a complete compromise of that particular user and also of all other users running on the same appliance, as we can repeat this process. Okay, so now that we have a basic understanding of how Symlinks can affect our shared hosting instances, it's time to look at a practical example here. So again, we are adding a WordPress website to our shared hosting, but inside the path input field, we actually specified a path traversal payload. So we are traversing out of our jailed web route into the var www default directory of the hosting appliance itself, so the machine where all the applications are running on, also of other users. So the interesting part here is when the application tries to install WordPress in the specified directory, it will also change the permissions of the target folder to read-write to my user, because it's installing WordPress inside that specific folder. So that will allow us to upload, for example, a web shell or some other malicious file into the web route of the hosting appliance. Now we only need a way to upload arbitrary files, of course, because now we're stuck with WordPress default files. So if we click the create button, and afterwards check the URL of the hosting appliance, so not our own application, but the hosting appliance, we can actually see that it is now running a WordPress instance on the unique string identifier here I created because I didn't want it to be detected by web application scanners. So we have now a confirmation our WordPress install actually worked. So the path traversal actually worked and WordPress is installed inside the hosting appliance. The second part of the exploit is actually the one that includes the Symlink vulnerability. So we can SSH into our shared hosting instance and create a symlink. Now, the command to do that is ln-s followed by your destination and ended by your source file. So in this case, we are creating a file called ftp link that is pointing to /var/dub. We can do a double check of the file and the destination by issuing a ls-al command, and the output will show you where the link is pointing to. Now, we can move over to our web control panel here to create a new FTP account. So this is actually the vulnerable component of the hosting provider platform here. So we can create a new FTP account and set the home directory to the symlink we just created. So if everything is working as we expect, then the home directory of the new user will actually be /var/dub. We can check that by going to a FTP client, such as FileZilla, for example, and just connect with the new user, and we should end up in the var/dub directory. Now we can already verify because you can see our unique string identifier here, in which we installed the WordPress application on the previous slide. So, as we mentioned earlier, because WordPress was installed inside this folder, we also have read and write access given to our shared instance user, which means we can now upload arbitrary files into the web root of the hosting appliance, such as a web shell, which effectively compromises the host where all other applications and users are running on. An interesting thing to note, though, is that we now targeted the hosting appliance web root, but we could have also targeted another user's web root. So we could have installed WordPress inside another user's jailed web root, and also created an FTP user with another user's web root as a home directory, and basically download all files or upload new files inside that user's website. Our next example involves a predefined application exploit. So our target hosting provider presents us a list of applications where we can just hit the Add New button, and that will be automatically installed inside our hosting package. Now, all of these applications have a folder where their files are stored. So how this essentially works is that the backend service that has to perform this operation needs to perform a recursive copy from the source where the applications are stored to our shared hosting instance. So that's about it. Now, what if we could find a way to write an arbitrary file, let's say a web shell or some other file, into that source folder of the application, or for all applications? That would essentially mean that every user that installs such predefined application would automatically copy over a backdoor that we included. Now, in order to do this, we need an arbitrary file. Right, so we need an elevated service that performs a file write into a target directory that we can control. Luckily for us, we found one. So there is a customs error pages component. So this is a vulnerable component where we can specify custom content for a specific response code. So in this example, we have a 400 bad request where we can specify, okay, show this error message when this response code occurs, and show a return to link with this text. Now, whenever we hit save and publish, this will essentially create a new HTML file inside our shared hosting instance web root in a subfolder called custom errors, and the file that is being written is called the response code.html. So if we could create a symlink already, maybe we can tell the application to write to another file outside of our jailed web root. In order to exploit this example, we need to SSH into our shared hosting instance and create a symlink. The source file for this symlink will be inside the custom errors subdirectory inside our jailed web root, and we will call it 400.html because that's the file where the custom errors component inside the web application will write to when we hit save and publish. Now our target file, I already know from previous reconnaissance on the system, we first need to traverse a few directories upwards, and then we can go into the specified application directory we want to target. In our case, the advanced guestbook application. Now I specified a target file called bitmap2.html. So this file doesn't exist yet, but it will if the application follows our symlink. So now that everything is settled, we can go ahead and go to the custom error pages component. Create a new entry for the 400 bad request response code. We will give it an error message of this is a file write from bitmap bug route bug bounty, and the default return text. Now we can hit save and publish, and hopefully our file is being written. So now it is time to actually check if our exploit worked or not. So we log into a second account on the target hosting provider, and we go to the predefined application component. We can now select the add new button of the advanced guestbook application and wait for the installer to end. So normally, if it worked, we should have a bitmap2.html file in our web application directory. So once the install finished, we can check our domain, and we can see here in the advanced guestbook subdirectory, a file called bitmap2.html has been created. So with our first user, we successfully created a backdoor inside everyone's web application that installs the advanced guestbook predefined application. This was the last example of Symlink vulnerabilities, so now it's time to move over to the next one. That will be a database vulnerability that we're going to exploit to read local files. Most hosting providers allow you to create databases for your web applications. So, for example, if you have a WordPress CMS or just an application that needs a database, they allow you to create it inside the web control panel. There you will get credentials so you can connect your application to it. Now, these databases are often run on a dedicated database server, which is also shared with other users and applications, which means if we get local access or remote code execution on the database servers, we also compromise other user data. We'll start with an example. This panel is being shown on a target hosting provider after installing the WordPress CMS. So basically, they allow you to restore a previously backup database in order to transfer your WordPress website from one hosting provider to another. Just restore the database and get your application up and running again. We can see they allow two types of input. So the first one is a URL where you can specify an endpoint. Then the backend of the hosting provider platform will fetch your backup file and will import it into a new database. The second one is a regular file upload where you can select your backup file from your local file system and import it that way. Now, the question is, how can we abuse a MySQL backup file in order to read files which we should not have access to? Enter load data local in file. So this SQL statement is being used to load the contents of a local file and use it to insert new records into a database server. A possible use case for this would be, for example, an IT systems operator that has a CSV file and wants to use the contents to insert new records into a server. Now, the difference here is that the client in our case is the backend server that is actually ingesting our backup file. So if we specify a load data local in file inside our backup file, it will actually use the file inside its own file system and insert that into the MySQL server, which we have access to. What we see here are the contents of the WordPress backup file. And you can see in the middle, we added a load data local infile statement, which will read the etc hostname file and put it into a table called test. The fields will be terminated by a new line character, which means a new record will be added for every line present in the source file here in the etc hostname file. Okay, so now we have everything up and running. So the only thing we have left to do is let the backend fetch our database backup file. Now, the vulnerable component was in the URI input field. So I decided to host the backup file on my VPS so the backend can fetch it that way. Now, if everything works as expected, the operation that ingests our MySQL backup file will read its local etc hostname file, which will be a backend server on the target hosting platform, and will put that contents of that file into our database where we have access to. So we'll see if that works out. So now we can connect to our MySQL database, and right off the bat, we can do a select star from test, which is the table where we put the file contents into. Now in the output, we can see the host name has been successfully added to the database, which means our attack worked. So of course, we also did the etc passwd file. So this actually proves the attack worked, and we can read local files from the backend service actually ingesting our backup file. Okay, guys, that was it for today. So I hope you guys enjoyed it. I want to really thank you for your attention. And also I want to thank Intigriti for giving me the opportunity to present this presentation. You can also follow me on Twitter. My handle is real_bitmap. And I also want to point out some other people that you can follow, which I know they also have done some research into the hosting provider targets. And I know they have some really cool vulnerabilities also in the other categories of functionalities and services they provide. For example, in DNS domains and stuff like this. So people you really need to follow as well are HDReal1 and at Sander Wind, who is also giving a presentation, by the way. So you can also reach out to those guys if you want to get into hosting provider hacking. So again, I really want to thank everyone and see you later. Bye-bye.